So just going around the circuit board, we've got a few inputs and outputs. This one here on the back, which is labelled as well, is the priority input. This will be where you put your sat-nav or whatever dominant audio source you want that's going to go over the top of the other one. In this one labelled the non-priority input, this is where you'd have your music and the input that you want to decrease in volume when the primary input comes on. Over here you've got a output. Now this is just driven by an op-amp, so it's designed to go into a high impedance amplifier. So if you're running this through another amplifier to drive your speakers, that should be absolutely fine. But it's not powerful enough to drive speakers directly, or headphones for that matter. And there's a JST connector here for the voltage input. All of the audio connectors are 3.5mm 3-pole headphone jacks. Right, so we're going to be taking a look at how some of the adjustment potentiometers work on the microduck PCB and what functions they perform and how to get it set up for your installation. So there's 3 potentiometers. There's sensitivity, attenuation and delay, and I'll just go through those one by one and show you what each one does. So to go over the function of the microduck again, we've got 2 inputs from this frequency generator setup. Channel 2 would be your music that would be coming from a Bluetooth device, something like that, and channel 1 would be something like a sat-nav that you'd want to override the music. So you can see this peak here, this is a Fft display, and it basically shows us the volume at different frequencies of a signal. So this is our music from channel 2, and when something comes from the sat-nav on channel 1, you can see that's just dropped down by division there. That corresponds to 10 dBV. So what we're basically seeing here is when this signal pops up, which would be from your sat-nav, it's lowering the volume of the other signal. So the first potentiometer we're going to look at is the sensitivity potentiometer. We need to set this up first because if the board isn't triggered, then we won't be able to set the attenuation because that part of the circuit won't be active. So it's basically a case of turning on your signal and finding the point at which the LED turns from off to on and just setting it maybe 1/5 of a turn anti-clockwise from where that LED is turned on. So once we've got that set up, we can have a look at the attenuation potentiometer, and what you'll see is as I twist that, the right hand peak will go up and down in amplitude. So turning it clockwise will take it right down into the noise. If you slowly turn it anti-clockwise, the volume of that duct channel, which would usually be your music, will increase, and you can set that to sort of whatever a comfortable level is. Just for an example, I've got that set about 80 degrees clockwise from the centre position of the pot, and right now the sensitivity is set to probably about 80 degrees counterclockwise from the centre position of the pot. Okay, so the final potentiometer is this delay potentiometer, and with that set fully clockwise, that'll give you basically 0 delay. So as soon as your sat-nav or whatever the primary source is turns off, that LED will turn straight off, and you'll see the volume of the non-priority input will shoot back up to its full volume straight away, like that. And if I turn that all the way anti-clockwise, that'll set the delay to the maximum, and you'll see if I turn it off now, which you'll hear with that beep, there'll be maybe the best part of a second while that to wait for that message to finish, and then the volume will come back up. So I'll press it now. You can see that's just come back up there.